Picture this, a shimmering halo of light, glowing like liquid gold against the blackened sky. It's the sun's corona, its outer atmosphere, revealing itself only during those rare moments when the moon slips perfectly between Earth and Sun, casting us into temporary twilight. But this isn't just a beautiful spectacle. It's a mystery wrapped in fire and magnetism, defying everything we think we know about heat and space. While the sun's surface burns at thousands of degrees, its corona blazes millions hotter, like a flame that grows fiercer the farther you step away from the fire. How can this be? What forces sculpt those wispy, ever-changing tendrils of plasma into such breathtaking shapes? Tonight, as you drift into relaxation, let's unravel the secrets of this celestial enigma, floating together where science meets wonder. And before we dive deeper, where are you watching from tonight, and what time is it there? Let's make this journey across the cosmos feel a little more connected. Now, close your eyes and imagine the corona's glow wrapping around you like a cosmic blanket, gentle yet full of hidden power. Now, let's peel back the layers of our sun, like unwrapping the secrets of a cosmic onion. At its heart, the sun is a roiling ball of nuclear fusion, but what we see, the part that lights up our sky, is just its outer personality. The first layer is the photosphere, the sun's surface, as we know it. This is the bright, familiar face of the sun, glowing at around 5,500 degrees Celsius. It's where sunspots form, those dark blemishes that come and go like freckles on a giant's cheek. Just above the photosphere lies the chromosphere, a thin, reddish layer that's often invisible to our eyes unless during a total solar eclipse. Here, temperatures climb to around 20,000 degrees Celsius, and spiky jets of plasma, called spicules, shoot upward like flames from a campfire. But the real marvel begins beyond this, in the corona, the sun's outer atmosphere. While the chromosphere and photosphere are hot, the corona is where things get truly baffling. It soars to temperatures of over 1 million degrees Celsius, defying logic. How can the sun's outer atmosphere be hundreds of times hotter than the surface beneath it? It's like standing near a bonfire and feeling the air around you grow scorching hot, while the flames themselves feel cooler. This is the Coronal Heating Problem, one of the greatest puzzles in solar science. And as we drift deeper into this mystery, remember the sun's layers aren't just boundaries. They're stages where the drama of heat, light, and magnetism unfolds in ways we're still learning to understand. Here's the next part of our journey into the sun's mysteries. Normally, the corona is like a whisper, lost in a shout, completely drowned out by the blinding light of the sun's surface. Our eyes can't see it, not because it isn't there, but because the photosphere, the sun's bright face, outshines everything around it. Imagine trying to spot a firefly right next to a spotlight. That's the challenge of observing the corona under ordinary conditions. But when a total solar eclipse sweeps across the Earth, something magical happens. The moon slides perfectly in front of the sun, blocking its intense glare for those precious few minutes. Suddenly, the corona reveals itself, a delicate, shimmering halo of pearly light, stretching millions of kilometers into space. Its wispy tendrils curl and sway, like silk caught in a gentle cosmic breeze. Some stream outward in long, feathery rays, while others loop back toward the sun, tracing the paths of invisible magnetic fields. During totality, the sky darkens to a deep twilight, and the corona glows with an otherworldly silver-white radiance. It's not the harsh, blinding light of the sun we know, but something softer, almost ghostly. Stars peek through the darkened sky, and the air grows still, as if the whole world is holding its breath. For centuries, this fleeting sight has left eclipse watchers spellbound, reminding us that the sun's true beauty often lies just beyond what we can normally see. And here's the wonder. The corona isn't just a pretty sight. Its visibility during eclipses has given scientists crucial clues about the sun's behavior, helping unravel the secrets of its scorching heat and turbulent magnetism. So the next time you hear about a total solar eclipse, remember, it's not just the moon hiding the sun. It's a rare invitation to glimpse the hidden crown of our solar system. Now, let's tackle one of the sun's most baffling secrets, the coronal heating problem. Picture this: the sun's surface, the photosphere, sizzles at around 5,500 degrees Celsius. That's hot enough to vaporize almost anything on Earth. But just above it, in the corona, temperatures skyrocket to millions of degrees. It's as if you walked away from a campfire and suddenly felt blistering heat instead of cooler air. How does this happen? Scientists have been scratching their heads over this for decades. One leading theory points to nanoflares, tiny explosions that erupt across the sun's surface. Think of them as countless sparklers lighting up all at once. Individually, each nanoflare is small, but together, they could pump enough energy into the corona to explain its extreme heat. Another idea involves magnetic waves. The sun's magnetic field is constantly twisting and turning, like an invisible cosmic dance. These movements create waves that travel upward, transferring energy into the corona like ripples in a pond. When these waves crash, they release heat, supercharging the outer atmosphere. But here's the twist: neither theory fully solves the puzzle. Some scientists believe it's a combination of both, with nanoflares and magnetic waves working together to keep the corona scorching hot. Others are exploring even wilder ideas, like tiny magnetic loops, reconnecting and releasing bursts of energy. What makes this mystery so thrilling is that every new solar mission, like the Parker Solar Probe, brings us closer to an answer. So while we don't have all the pieces yet, one thing's certain: the sun's corona is a cosmic furnace defying our expectations, and uncovering its secrets could rewrite what we know about stars, and maybe even the universe itself. Now, let's turn our attention to the invisible force sculpting the sun's corona, its magnetic fields. Imagine the sun as a giant spinning magnet with lines of magnetic force stretching far into space. These fields don't just sit still, they twist, tangle, and snap like rubber bands, shaping the corona into breathtaking structures. One of the most stunning sights are coronal loops, massive arches of glowing plasma that stretch thousands of kilometers above the sun's surface. Picture them as celestial bridges, with superheated gas flowing along magnetic lines like cars on a highway. Then there are the streamers, wispy tendrils that fan outward during eclipses, resembling a crown of light. And let's not forget solar prominences, those fiery ribbons that erupt from the surface, sometimes lingering for weeks like slow-motion fireworks. What's mesmerizing is how these features move. The corona isn't chaotic. It's more like a carefully choreographed dance. Magnetic fields guide the plasma in graceful arcs, while sudden reconnections send energy surging through the atmosphere. It's a ballet of fire and force, where every movement tells a story about the sun's hidden power. And here's the kicker: these magnetic dances aren't just beautiful. They're key to solving the coronal heating mystery. When fields collide or snap, they release energy, potentially explaining why the corona burns so hot. Missions like the Parker Solar Probe are now tracing these magnetic pathways, uncovering secrets that could finally crack the code. So next time you see an image of the sun's corona, remember, you're not just looking at random swirls of gas. You're witnessing a cosmic performance where magnetic fields pull the strings and the corona dances to their tune. Now, let's follow the energy flowing outward from the sun's corona to discover how it shapes the space around us. The same scorching heat that makes the corona such a puzzle also fuels an incredible phenomenon: the solar wind. This isn't just a gentle breeze. It's a supersonic river of charged particles, mostly electrons and protons, racing away from the sun at speeds up to 1 million miles per hour. Think of the corona as a cosmic pressure cooker. The intense heat gives these particles so much energy that the sun's gravity can't hold them back. They break free, streaming into space in all directions. Some flow steadily from coronal holes, those darker, cooler regions where magnetic fields open like windows. Others burst out in gusts during solar storms, when tangled magnetic lines snap and fling material outward. This wind doesn't just vanish into the void. It carries the sun's influence across the solar system, shaping planets and painting the sky with auroras. When those charged particles collide with Earth's magnetic field, they're funneled toward the poles, sparking dazzling light shows. But the solar wind can also stir up trouble, disrupting satellites, nudging spacecraft off course, and even threatening astronauts with radiation. What's fascinating is how long this wind has been blowing. For billions of years, the corona has been shedding particles, slowly stripping away the sun's mass. Over time, it sculpted comet tails, eroded Martian air, and even helped determine which planets could hold onto their atmospheres. So while we often focus on the sun's light, its invisible wind is just as vital, a silent force connecting every corner of our cosmic neighborhood. As we trace this flow of particles back to its source, we're reminded that the corona isn't just a spectacle. It's a dynamic engine, powering a solar wind that touches everything in its path. But sometimes, the sun doesn't just send a steady wind, it throws a tantrum. Picture this: a colossal eruption on the sun's surface, where twisted magnetic fields suddenly snap like overstretched rubber bands. In an instant, the corona hurls 1 billion tons of superheated plasma into space at mind-blowing speeds. This is a coronal mass ejection, one of the most powerful explosions in our solar system. These eruptions are both breathtaking and terrifying. Imagine a cloud of charged particles, glowing like molten gold, racing outward at several million miles per hour. Some are so vast they could swallow Earth whole. When one heads our way, it can light up the sky with auroras so intense they've been mistaken for dawn in the middle of the night. But their beauty hides a dangerous side. That same storm of particles can wreak havoc on our technology. When a coronal mass ejection slams into Earth's magnetic field, it creates violent electric currents in power lines, risking blackouts that could last for days. Satellites caught in the crossfire might tumble out of control or lose communication. Even astronauts in space could face dangerous radiation levels. The most famous example, the Carrington event of 1859, a coronal mass ejection so strong it set telegraph offices on fire and sparked auroras visible near the equator. If something like that happened today, with our reliance on electronics, the damage could be catastrophic. Yet, these explosions also remind us of the sun's raw power. They're part of a cosmic dance, a reminder that even from 93 million miles away, our star's tantrums can reach out and touch us. And as we learn to predict them better, we're not just studying space weather, we're preparing to protect the delicate web of technology that keeps our modern world running. Now, let's explore how these solar outbursts shape the invisible forces around us, creating what scientists call space weather, a phenomenon that turns the space between the sun and Earth into a dynamic, ever-changing frontier. Now, let's step into the invisible currents that flow between the sun and Earth, where the sun's tantrums shape what scientists call space weather. Think of it as a conversation where the sun sends out bursts of energy and Earth's magnetic field responds in its own way. One of the most stunning replies in this cosmic dialogue, auroras, when charged particles from the sun collide with Earth's atmosphere near the poles, they paint the sky with shimmering curtains of green, pink, and purple. These lights aren't just beautiful, they are a sign of our planet's magnetic shield, bending and flexing under the sun's influence. But not all of this conversation is peaceful. The same particles that create auroras can also scramble the signals of satellites orbiting Earth. Imagine your GPS suddenly losing its way, or your favorite streaming service cutting out, all because of a solar storm. For astronauts on the International Space Station, the risk is even greater. Without Earth's thick atmosphere to protect them, they're more exposed to harmful radiation during intense space weather events. Even our power grids join this cosmic exchange. When a surge of solar particles distorts Earth's magnetic field, it can induce powerful electric currents in power lines, like an unwelcome guest overloading the circuits. Engineers now design safeguards to brace for these solar surprises, but a major storm could still plunge entire regions into darkness. Yet, there's something poetic about this give and take. The sun, from nearly 100 million miles away, stirs the air around us, lights up our skies, and even nudges our technology. It's a reminder that we're not just neighbors in space. We're part of an ongoing cosmic dance, one where the sun leads and Earth follows, sometimes gracefully, sometimes with a stumble. And as we learn to listen more closely to this dialogue, we're not just uncovering the sun's secrets, we're learning how to live in harmony with our star's fiery temper. Long before telescopes and satellites, humans gazed at the sun with a mix of awe and fear, especially when its light suddenly vanished during an eclipse. Ancient civilizations saw these moments as powerful omens. The Chinese believed a celestial dragon was devouring the sun, while Norse myths warned of sky wolves chasing it. To them, the corona's wispy glow wasn't just a spectacle. It was a message from the gods, a sign of coming wars, famines, or the fall of kings. Then came the pivotal year, 1869, when scientists turned superstition into science. During a total eclipse, astronomers spotted a strange green line in the corona's light, a spectral signature they thought belonged to a new element, which they named coronium. Decades later, the mystery unraveled. Coronium wasn't a new element at all, but superheated iron atoms, stripped of half their electrons in the corona's extreme heat. This failed discovery became a crucial clue, revealing just how blisteringly hot the sun's outer atmosphere really was. From dread to curiosity, humanity's relationship with the corona mirrors our journey to understand the cosmos itself. What was once a divine warning is now a window into the sun's fiery heart, and a reminder that even our mistakes can light the way to truth. Next, we'll explore the cutting-edge tools that let us study the corona today, not just during eclipses, but every single day. Now, let's step into the world of modern science, where we no longer wait for eclipses to reveal the sun's secrets. Today, we have ingenious tools designed to study the corona around the clock. One of the most brilliant inventions is the coronagraph, a device that mimics an eclipse right inside a telescope. By blocking the sun's blinding disk, it lets us see the delicate glow of the corona anytime, not just during those rare celestial alignments. But why stop at Earth? Scientists have sent daring missions straight into the sun's fiery embrace. Take the Parker Solar Probe, for example, a spacecraft built to withstand temperatures that would melt most metals. It flies closer to the sun than any human-made object in history, skimming through the corona itself to measure its heat, magnetic fields, and the wild solar wind. Each pass reveals new details, like how the corona's plasma dances in loops and swirls, guided by invisible magnetic forces. And then there's the Solar Dynamics Observatory, a satellite that watches the sun non-stop, capturing ultra-high-definition images of solar flares, coronal loops, and explosive eruptions. These tools don't just satisfy curiosity, they help us predict space weather, shielding satellites and power grids from the sun's tantrums. From artificial eclipses to fearless probes, humanity's quest to understand the corona has turned ancient wonder into cutting-edge discovery. Next, we'll follow the Parker Solar Probe on its perilous journey, diving deeper into the sun's scorching atmosphere than ever before. Now, picture this: a spacecraft on a mission so bold, it's been called touching the sun. The Parker Solar Probe isn't just another satellite. It's a technological marvel built to endure the unimaginable. Launched in 2018, this fearless explorer races toward the sun at speeds topping 430,000 miles per hour, fast enough to fly from New York to Tokyo in under a minute. But speed isn't its only superpower. To survive the corona's brutal heat, reaching nearly 2 million degrees Fahrenheit, the probe hides behind a revolutionary heat shield. This carbon composite armor, no thicker than a phone book, deflects the sun's fury, keeping the spacecraft's instruments at a cozy 85 degrees. Think of it as a knight's shield, but for science. And what does it find in this inferno? Turbulence unlike anything near Earth. The corona isn't just hot, it's alive with magnetic chaos. The probe has detected tiny switchbacks, sudden zigzags in the solar wind, hinting at how the sun's magnetic fields twist and snap, flinging energy into space. Each orbit peels back another layer of the corona's mysteries, like a detective uncovering clues in a cosmic crime scene. Yet the most astonishing revelation: the corona's particles accelerate faster than theories predicted. It's as if the sun has secret engines we're only now discovering. With every perilous loop around our star, the Parker Solar Probe rewrites the textbooks, proving that to understand the sun, sometimes you have to get dangerously close. Next, we'll zoom in on one of the corona's most mesmerizing features, those fiery arches known as coronal loops, where plasma dances in a magnetic ballet. Now, let's turn our gaze to one of the corona's most breathtaking spectacles, coronal loops. Imagine vast, glowing arches stretching across the sun's surface, each one a river of superheated plasma flowing along invisible magnetic tracks. These loops aren't just static decorations, they're dynamic, ever-changing structures, some towering hundreds of thousands of miles high, far taller than Earth itself. Picture them as celestial bridges, connecting regions of opposite magnetic polarity. The plasma within these loops, heated to millions of degrees, follows the sun's magnetic fields like cars on a roller coaster, racing up and down in a fiery dance. Some loops last for hours, while others vanish in minutes, collapsing or reconfiguring as the magnetic landscape shifts. What makes them even more fascinating is their role in the corona's heating mystery. Scientists believe these loops are key to understanding how energy travels from the sun's surface into its outer atmosphere. When magnetic fields twist and reconnect, they release bursts of energy, like snapping a rubber band, heating the plasma and fueling these luminous arcs. And just like roller coasters, coronal loops come in all sizes. Some are compact and dense, while others stretch so far they could wrap around Earth dozens of times. The largest ones often appear during solar maximum, when the sun's activity peaks, painting its atmosphere with these radiant sculptures. Next, we'll witness another marvel of the corona, solar prominences, where plasma erupts in slow motion, fireworks that defy gravity itself. Now, let's shift our attention to another stunning feature of the sun's corona, solar prominences. These colossal eruptions are like nature's slow-motion fireworks, stretching hundreds of thousands of miles into space. Unlike the brief flashes of earthly fireworks, prominences can linger for days or even weeks, their glowing plasma suspended in graceful arcs above the sun's surface. What's truly mesmerizing is how they defy gravity. Picture a river of fire rising from the sun, not falling back immediately, but instead floating in midair, held aloft by the sun's powerful magnetic fields. These magnetic forces twist and loop, creating invisible scaffolding that guides the plasma into breathtaking shapes, some resembling towering fountains, others forming vast, curling ribbons. Prominences are deeply connected to the corona's ever-changing dynamics. When the sun's magnetic fields become tangled, they can suddenly snap, releasing enormous amounts of energy. This explosive reconnection hurls plasma outward, forming the dramatic loops we see as prominences. Sometimes, these eruptions break free entirely, launching into space as part of a coronal mass ejection, a storm of charged particles that can travel across the solar system. But not all prominences end in violence. Many simply fade away, their plasma cooling and raining back down onto the sun's surface in what scientists call coronal rain. This eerie phenomenon looks like glowing droplets falling in slow motion, a quiet contrast to the sun's usual fury. Whether they erupt or gently dissolve, prominences remind us that the corona is never still. It's a place of constant motion, where magnetic forces sculpt the sun's atmosphere into ever-shifting masterpieces. Next, we'll explore the darker, cooler regions of the corona coronal holes and how they shape the solar wind. Now, let's turn our gaze to the quieter, darker corners of the sun's corona coronal holes. Unlike the fiery loops and eruptions we've explored, these regions appear as vast, shadowy patches against the sun's glowing surface. But don't let their dim appearance fool you. Coronal holes play a crucial role in shaping the solar wind, the constant stream of charged particles flowing from the sun into space. What makes these areas so different? It all comes down to magnetic fields. In most of the corona, magnetic fields loop back onto the sun, trapping plasma and creating those dazzling structures like prominences. But in coronal holes, the magnetic fields stretch outward, opening like unfurled ribbons into space. This allows solar wind particles to escape more easily, racing away at speeds nearly twice as fast as the usual solar wind. These holes aren't random. They follow patterns tied to the sun's 11-year activity cycle. During quieter phases of the cycle, coronal holes often linger near the sun's poles. But as activity ramps up, they can appear closer to the equator, sending faster solar wind toward Earth. When that happens, the effects ripple across our planet, triggering vivid auroras or, occasionally, disrupting satellite communications. Think of coronal holes as cosmic wind tunnels, channeling the sun's breath into the solar system. Their influence reaches far beyond their dark, unassuming appearance, reminding us that even the quietest parts of the corona hold power over the space around us. Next, we'll see how the entire corona transforms over time, dancing to the rhythm of the sun's mysterious cycles. Now, let's journey through time with the sun's 11-year cycle, a rhythmic dance of activity that transforms the corona from serene to stormy. Picture the sun as a living, breathing entity, its mood shifting over a decade-long heartbeat. At the start of the cycle, the corona is relatively calm, with fewer sunspots and a more orderly magnetic field. Coronal holes often dominate the poles, and the solar wind flows steadily but gently. But as the cycle progresses, the sun wakes up. Sunspots, those dark, cooler patches on its surface, begin to multiply like freckles under a summer sun. These sunspots are markers of tangled magnetic fields, and where they appear, the corona responds with fiery energy. Loops of plasma grow more numerous and dynamic, arching high above the sun's surface. Solar flares and coronal mass ejections become frequent, hurling bursts of radiation and charged particles into space. By the peak of the cycle, the corona is a tempest, Sunspots cluster near the equator, and the entire atmosphere crackles with activity. Even coronal holes, once confined to the poles, can drift lower, sending faster solar wind our way. This is when Earth might witness the most intense auroras, or face the brunt of disruptive space weather. Then, like a storm passing, the sun begins to quiet. Sunspots fade, the magnetic field simplifies, and the corona returns to a state of tranquility. But this calm is only temporary. Beneath the surface, the sun is already preparing for its next cycle, gathering energy for another 11-year performance. This ebb and flow isn't just a spectacle, it's a reminder of how deeply connected we are to our star. Every shift in the corona echoes across the solar system, touching everything from satellite signals to the shimmering northern lights. And as we watch this cosmic rhythm unfold, we're glimpsing the heartbeat of the sun itself. Next, we'll meet the passionate eclipse chasers who travel the world just to witness the corona's fleeting glory. Now, imagine packing your bags not for a beach or a mountain getaway, but for a fleeting moment when the moon perfectly covers the sun. These are the eclipse chasers, dedicated travelers who crisscross the globe, chasing the shadow of totality, just to stand beneath the sun's shimmering corona. For them, it's not just an event, it's a pilgrimage. Picture this: the sky darkens in the middle of the day, the temperature drops, birds stop singing, confused by the sudden twilight. Then, as the last sliver of sunlight vanishes, the corona bursts into view, a delicate, pearly halo with wispy tendrils stretching millions of miles into space. In that instant, time seems to freeze. Some people gasp, others cry, many are struck silent, overwhelmed by the sheer grandeur of our star's hidden atmosphere. These chasers aren't just casual observers. They study weather maps, book flights years in advance, and even reroute vacations just to be in the moon's shadow for those precious few minutes. Some have witnessed dozens of eclipses, yet each one feels brand new, because no two coronas are alike. Depending on the sun's mood during its 11-year cycle, the corona might appear as a symmetrical glow or a wild tangle of fiery plumes. And it's not just about the science. There's something deeply human about standing under a darkened sky, united with strangers in collective awe. In that moment, the corona isn't just a scientific puzzle, it's a reminder of our tiny place in a vast, beautiful universe. Next, we'll explore how artists and filmmakers have tried to capture the corona's magic, from scientific renderings to dazzling sci-fi imaginings. Now, let's step into the world of creativity, where the corona's ethereal beauty has inspired artists and filmmakers for generations. From painstakingly accurate scientific illustrations to wild, imaginative portrayals in science fiction, the sun's outer atmosphere has been reimagined in countless ways. Take NASA visualizations, for example. Using data from satellites and space probes, their artists craft stunningly realistic depictions of the corona, dynamic loops of plasma, swirling magnetic fields, and explosive solar flares. These images aren't just pretty pictures. They help scientists and the public alike visualize the invisible forces shaping our star. The corona's delicate tendrils and fiery arcs come to life in vibrant detail, making the sun's hidden drama accessible to everyone. But then there's sci-fi, where the corona becomes a canvas for pure imagination. In movies and TV shows, it's often portrayed as a raging inferno, a celestial storm, or even a gateway to other dimensions. Some films exaggerate its scale, turning it into a swirling vortex of energy, while others use it as a backdrop for epic space battles. These creative liberties might not be scientifically precise, but they capture something just as important: the awe and mystery the corona inspires. Even painters and digital artists have tried to bottle its magic. Some blend realism with dreamlike colors, turning the corona into a radiant crown of light. Others take abstract approaches, using bold strokes and surreal palettes to convey its otherworldly energy. Whether hyper-detailed or wildly interpretive, these works remind us that the corona isn't just a scientific wonder. It's a muse, and here's something fascinating. The way we picture the corona often reflects our understanding of it. Early artists, limited by the technology of their time, painted it as a simple golden halo. Today, with advanced telescopes and space missions, our depictions have grown more intricate, mirroring our deepening knowledge. Yet no matter how much we learn, the corona keeps its mystique, always just out of reach, always inspiring new visions. Next, we'll travel even further back in time, to the myths and legends that once saw the corona as a divine crown, worn by gods of fire and light. Long before telescopes and space probes, the corona was already a source of wonder, woven into the myths and legends of cultures across the world. Picture ancient civilizations gazing up during a solar eclipse, seeing the sun's shimmering halo and believing it was the crown of a god. To the Egyptians, it was the radiant glow of Ra, the sun deity, sailing his fiery boat across the sky. His crown wasn't just light, it was power, life, and divine authority. The Greeks saw Apollo's chariot racing through the heavens, its golden reins scattering rays of light we now know as the corona's tendrils. In Hindu tradition, the corona's arcs mirrored the flaming hair of Surya, the sun god, whose radiance sustained all creation. These stories weren't just fanciful tales. They were attempts to explain the unexplainable, to give shape to the sun's mysterious aura long before science could. Even the name, corona, comes from the Latin word for crown, a nod to how the ancients perceived it. Some cultures interpreted eclipses and the sudden visibility of the corona as omens. The Inca feared the sun was angry, while the Chinese believed a celestial dragon was devouring it. Yet in every legend, the corona remained a symbol of something greater, the boundary between the ordinary and the divine. What's remarkable is how close some myths came to the truth. The Maori of New Zealand described the sun as having rays that could stretch and twist, eerily resembling the magnetic loops we now study. Indigenous Australian stories spoke of the sun's spirit energy, reaching out like tendrils, almost predicting the solar wind. These weren't just poetic coincidences, they were observations passed down through generations, hinting at truth science would later confirm. Today, we understand the corona as superheated plasma and tangled magnetic fields. But the old stories still resonate. They remind us that the urge to explain the cosmos is timeless, whether through science or myth, and perhaps that's the real magic of the corona. It bridges our past and present, connecting the awe of ancient stargazers to the curiosity of modern explorers. Next, we'll fast forward to the cutting-edge missions daring to touch the sun itself, where today's scientists chase answers to the corona's enduring riddles. Now, let's turn our gaze to the future, where the next generation of solar explorers is preparing to unlock even deeper secrets of the corona. Imagine spacecraft engineered to withstand temperatures that would melt steel, flying closer to the sun than ever before. Leading this daring charge is the European Space Agency's Solar Orbiter, a mission designed to capture the first ever close-up images of the sun's poles. Equipped with cutting-edge instruments, it will trace how magnetic fields twist and erupt, potentially solving the riddle of why the corona burns so fiercely. But the Solar Orbiter isn't alone. NASA Parker Solar Probe, humanity's first mission to touch the sun, continues its record-breaking journey, diving through the corona itself. By skimming just 4 million miles from the sun's surface, closer than Mercury's orbit, it measures the solar wind's birth and the electric currents that heat the corona. Already, it's discovered switchbacks, sudden zigzags in the solar wind that may hold clues to the corona's extreme temperatures. What's next? Missions like India's Aditya L1 aim to study the corona's layered dynamics, while proposed projects could deploy fleets of tiny satellites to map its magnetic web in 3D. Each mission builds on the last, like pieces of a cosmic puzzle. Together, they might finally explain how this crown of fire defies the laws of physics, and how its tantrums shape the space around our planet. The answers won't just satisfy curiosity, they'll help us predict solar storms that threaten satellites and power grids, turning ancient awe into modern resilience. As these robotic pioneers brave the sun's fury, they carry forward the same question that once haunted mythmakers: what truly powers the star that gives us life? Now, let's explore one of the most fascinating theories behind the corona's blistering heat: Alphane waves. Picture these as invisible ripples racing through the sun's magnetic fields, like energy highways pulsing with power. Named after the Nobel Prize-winning scientist Hans Alphane, these waves are thought to carry energy from the sun's churning interior all the way up to its outer atmosphere. Here's how it works. The sun's surface is constantly in motion, bubbling with turbulence that jostles its magnetic field lines. This creates waves that travel along those lines, much like vibrations racing down a guitar string. As these Alphane waves speed outward, they grow stronger, eventually crashing into the corona like ocean waves hitting a cliff. The energy they release could be the missing piece that explains why the corona is so unimaginably hot. Millions of degrees, far hotter than the sun's surface below. Scientists believe these waves might act like a cosmic delivery system, transporting heat where it's needed most. Some even compare them to invisible freight trains, hauling energy across the sun's atmosphere. But unlike trains, Alphane waves move at staggering speeds, sometimes hundreds of thousands of miles per hour. The Parker Solar Probe has already detected hints of these waves during its daring dives through the corona. Its findings suggest they might play a bigger role than we ever imagined. If confirmed, this could rewrite our understanding of how stars heat their outer layers, not just our sun, but countless others across the universe. So next time you see an image of the sun's shimmering corona, remember, Those delicate loops and streamers might be dancing to the rhythm of Alphane waves, an invisible force turning the solar atmosphere into a furnace of light and energy. Now, let's turn our attention to another intriguing idea that could explain the corona's extreme heat, the nanoflare theory. Imagine the sun's surface not as a calm, steady furnace, but as a place buzzing with countless tiny explosions, each one too small to notice on its own, but together, packing enough punch to superheat the entire corona. Think of it like a field of sparklers on a dark night. A single sparkler might not light up much, but thousands of them together can create a dazzling glow. In the same way, scientists believe the sun's corona might be heated by an endless barrage of minuscule eruptions called nanoflares. These aren't the massive solar flares you've heard about. They're far smaller, but they happen constantly, like popcorn popping in a cosmic microwave. Here's why this matters. Each nanoflare releases a burst of energy as magnetic field lines on the sun's surface twist, snap, and reconnect. While one nanoflare might not do much, over time, their combined energy could be enough to explain why the corona is so much hotter than the layers below. It's like turning up the heat with countless tiny matches instead of one big bonfire. The challenge: nanoflares are incredibly hard to detect. They're so brief and faint that even our most advanced telescopes struggle to spot them. But recent observations from missions like the Parker Solar Probe and the Solar Dynamics Observatory have picked up hints of these tiny bursts, giving scientists hope that they might finally solve the coronal heating mystery. If the nanoflare theory holds up, it would mean the sun's corona isn't just heated by one big process, but by a symphony of tiny, chaotic events, each one a small piece of a much larger puzzle. So next time you see the sun's shimmering outer atmosphere, remember, it might be powered by an invisible fireworks show, lighting up the solar sky, one tiny explosion at a time. Now, let's take a closer look at one of the most mesmerizing and violent phenomena in the solar corona: solar tornadoes. Picture massive whirlwinds of superheated plasma, twisting and churning high above the sun's surface. These aren't like the tornadoes we see on Earth. They are made of electrified gas, stretching tens of thousands of miles into space, spinning at speeds that would make any earthly storm seem slow motion. What makes these solar tornadoes so fascinating is their sheer scale and energy. Some of them can reach heights several times taller than Earth itself, with magnetic fields acting like invisible hands, whipping the plasma into frenzied spirals. The temperatures here are unimaginable, reaching millions of degrees, yet the way they move has an eerie, almost graceful quality, like a cosmic dance of fire and magnetism. Scientists believe these tornadoes form when the sun's magnetic field lines get twisted and tangled, creating swirling funnels of plasma. The same forces that heat the corona also drive these vortices, making them a key piece of the puzzle in understanding our star's outer atmosphere. And while they might look chaotic, there's a strange order to their movement, as if the sun is sculpting its own storms with invisible threads of magnetic energy. The beauty of these tornadoes is matched only by their ferocity. Some spin so fast that they fling plasma outward, contributing to the solar wind that streams across the solar system. Others collapse in on themselves, vanishing as quickly as they appeared, Studying them isn't easy. They are fleeting, unpredictable, and often hidden in the sun's blinding glare. But missions like the Solar Dynamics Observatory have captured stunning footage, revealing their hypnotic swirls in extreme ultraviolet light. So the next time you think of tornadoes, remember the sun has its own version, far more powerful and mysterious. They are a reminder that even in the chaos of space, there's a kind of terrifying beauty, a dance of fire and force that we're only beginning to understand. But just when you think the sun's corona couldn't get any more surreal, there's something even stranger: coronal rain. Imagine fiery droplets, glowing like molten jewels, falling back onto the sun's surface in a slow, hypnotic downpour. It's one of the most hauntingly beautiful sights in our solar system, a stark contrast to the violent tornadoes we just explored. Here's how it happens. Sometimes, loops of plasma in the corona, those towering magnetic arches, cool down just enough for the superheated gas to condense. Think of it like steam turning back into water, but on a cosmic scale. Instead of water droplets, you get blobs of plasma, some as large as entire countries, tumbling along the sun's magnetic field lines like beads on a wire. They don't fall fast. This rain moves at a leisurely pace, taking hours or even days to complete its journey. What's truly mesmerizing is the glow. These droplets aren't just hot, they are scorching, even by solar standards. Yet compared to the surrounding corona, they're relatively cool, which makes them stand out in observations. When scientists capture this phenomenon in extreme ultraviolet light, it looks like a celestial waterfall, a shimmering curtain of fire cascading back to the surface. Coronal rain isn't just a spectacle, it's a clue. The way it forms and falls helps researchers understand how energy moves through the corona. Some theories suggest these droplets are the aftermath of solar flares or nanoflares, tiny explosions that heat the corona but leave behind pockets of cooler, denser plasma. Watching where and how the rain falls gives scientists a roadmap of the sun's hidden magnetic highways. And here's the twist. Sometimes, the rain doesn't make it all the way down. The sun's magnetic fields can flick it back upward, like a cosmic trampoline, sending the plasma soaring into the corona again. It's a reminder that even in the sun's chaotic atmosphere, there's a rhythm, a cycle of rise and fall that plays out in slow motion. So next time you see rain on Earth, remember the sun has its own version, far more exotic and mysterious. It's a delicate dance of fire and magnetism, a fleeting glimpse into the forces that shape our star's crown. Now, let's tune into something truly extraordinary, the sun's own music. Deep beneath its fiery surface, our star hums with sound waves, a cosmic symphony that scientists study through a field called heliosismology. Just like earthquakes reveal secrets about Earth's interior, these solar vibrations help us understand the sun's hidden layers and how they might even energize the mysterious corona. Picture the sun as a giant, resonating bell. Convection currents, those churning movements of hot plasma, generate pressure waves that ripple outward, bouncing between the surface and the core. Some of these waves have frequencies so low they'd be impossible for human ears to hear, but if we could speed them up, they'd sound like deep, pulsing notes. Scientists track these vibrations using special instruments, mapping how they travel through the sun's interior. It's like taking an ultrasound of a star. Here's where it gets fascinating. Some researchers believe these sound waves could play a role in heating the corona. As the waves travel upward, they might transform into different types of energy, like magnetic waves or shock waves, transferring heat to the outer atmosphere. Think of it as the sun's own way of turning sound into fire, a celestial conductor orchestrating energy from the depths to the crown. But the symphony isn't perfectly harmonious. Turbulence, magnetic fields, and the sun's rotation distort the waves, creating a cacophony of echoes that scientists must decode. By studying these distortions, they can infer details about the sun's structure, rotation, and even the movements of plasma beneath the surface. It's a bit like listening to a choir, where every off-key note tells a story about the singer's environment. And just like music, these sound waves have rhythm. Some pulse every 5 minutes, a slow, steady heartbeat of the sun, while others are faster, more erratic. Together, they create a dynamic soundtrack to our star's life, one that might hold the key to unlocking why the corona burns so fiercely. So next time you hear the wind rustle or birds sing, remember, the sun has its own melody, a hidden song of heat and motion that echoes across space. And with every vibration, it whispers clues about the mysteries of its glowing crown. Now, let's shift our gaze to a different kind of light, one that's invisible to our eyes, but holds the key to unraveling the corona's secrets. The sun's outer atmosphere blazes with extreme ultraviolet light, a form of high-energy radiation that our everyday vision can't detect. While we bask in the sun's visible glow, this hidden light reveals the corona's true nature, painting a picture of its staggering heat and activity. Extreme ultraviolet light, or UV for short, is produced by the corona's superheated gases. At temperatures reaching millions of degrees, the atoms in the corona become so energized that they emit this intense light. It's like the difference between a candle's gentle flicker and the blinding flash of a welding torch. Both are light, but one carries far more energy. Scientists use special telescopes and satellites equipped with UV sensors to capture this invisible glow, transforming it into images we can see. These snapshots show the corona not as a faint halo, but as a dynamic, roiling sea of plasma, threaded with magnetic loops and speckled with bright, explosive regions. What makes UV light so crucial is its direct link to the corona's temperature. By studying the wavelengths and intensity of this radiation, researchers can measure how energy moves through the sun's outer atmosphere. For example, certain UV wavelengths correspond to specific elements, like iron or oxygen, which only emit light at extreme temperatures. When these signatures appear, they're like cosmic thermometers, confirming just how blisteringly hot the corona really is. But there's a catch. Earth's atmosphere absorbs most UV light before it reaches the ground, which is why we need space-based observatories to study it. Missions like NAS, a solar dynamics observatory, orbit above our planet, staring unblinkingly at the sun, capturing every ripple and flare in this high-energy light. Without these tools, the corona's most telling clues would remain locked away, invisible to us. So while our eyes see a tranquil yellow disk in the sky, the truth is far more dramatic. The corona's extreme ultraviolet light is a silent scream of heat and motion, a language of energy that scientists are only beginning to translate. And with every new observation, we come closer to understanding why this enigmatic outer layer burns so fiercely against the cold darkness of space. Now, let's untangle two of the sun's most dramatic outbursts, solar flares and coronal mass ejections. While both erupt from the corona and unleash incredible energy, they're as different as lightning is from a hurricane. Solar flares are sudden, intense bursts of radiation, like cosmic flashbulbs going off. They happen when tangled magnetic fields near sunspots snap and reconnect, releasing energy across the electromagnetic spectrum, from radio waves to X-rays. Lasting just minutes to hours, flares light up the corona with brilliant flashes, sometimes outshining the entire sun for a brief moment. But their energy travels at the speed of light, meaning their effects, like radio blackouts on Earth, can hit us in just over 8 minutes. Coronal mass ejections, or CME, are slower but far more massive. Picture a billion-ton cloud of plasma being hurled into space, not at light speed, but at a leisurely million miles per hour. These eruptions occur when the sun's magnetic loops stretch too far and rupture, catapulting part of the corona itself outward. Unlike flares, CMEs are physical storms of charged particles that can take days to reach Earth. When they do, they don't just cause auroras, they can warp our planet's magnetic field, threatening satellites and power grids. Here's the key connection to the corona. Both events are born from its restless magnetic dance. Flares often accompany CMEs, but not always. Think of flares as the sun's scream and CMEs as its punch. One is energy, the other is matter. Together, they remind us that the corona isn't just hot and beautiful, it's a powerhouse of chaos, shaping space, weather across the solar system. Next time you hear about a solar storm, you'll know whether it's a flash or a freight train coming our way. And as we'll soon see, these explosions aren't just destructive, they're part of the sun's fiery conversation with the cosmos. But what if the sun's corona wasn't the dynamic, ever-changing force we know? Let's imagine a quieter sun, one with a static corona, where magnetic fields never twist and solar storms never erupt. At first glance, it might seem peaceful, but the consequences would ripple far beyond our star. Without the corona's constant activity, space weather as we know it would vanish. No solar wind means no gentle stream of particles to push against cosmic rays, leaving Earth more exposed to high-energy radiation from deep space. Auroras, those dazzling light shows near the poles, would fade into memory, since they're fueled by charged particles colliding with our atmosphere. Even our satellites would face fewer threats, but at the cost of losing the solar wind's protective bubble, which helps shield our solar system from interstellar dust and radiation. Earth's climate might shift in unexpected ways too. Some scientists suggest subtle links between solar activity and weather patterns, though the details are still debated. A static corona could mean fewer fluctuations in the sun's energy output, potentially stabilizing temperatures, or, paradoxically, making our planet more vulnerable to other cosmic influences. And without coronal mass ejections, the gentle erosion of our atmosphere over time might slow, altering the delicate balance that makes Earth habitable. Most strikingly, life itself might have taken a different path. The sun's storms, while disruptive, could have played a role in shaping Earth's early chemistry, even influencing the spark of life. Less ultraviolet radiation from a quiet corona might have slowed the evolution of protective features in organisms, like DNA repair mechanisms. And without the occasional solar upheaval, would life have developed the resilience to survive other cosmic challenges? A static corona paints a picture of a calmer solar system, but also a lonelier one, stripped of the sun's fiery dialogue with its planets. It's a reminder that the corona's chaos isn't just spectacle, it's part of a delicate cosmic dance that, for better or worse, made our world what it is today. Now, let's turn our gaze beyond the sun to the coronas of other stars, each with its own story to tell. But the sun isn't the only star with a shimmering crown, far from it. Across the cosmos, stars of all sizes and ages wear their own coronas, each one a unique fingerprint of stellar activity. Take red dwarfs, for example. These small, dim stars may seem unassuming, but their coronas often burn even hotter and more violently than our suns. Their frequent, intense flares can strip atmospheres from nearby planets, making them unlikely hosts for life as we know it. Then there are the hypergiants, massive, luminous stars that dwarf our sun in every way. Their coronas stretch across unimaginable distances, threaded with magnetic fields so powerful they could swallow entire solar systems. Yet despite their grandeur, these stars are fleeting, burning through their fuel in just a few million years before erupting in spectacular supernova. Even stars that seem similar to our sun reveal surprises. Some sun-like stars have coronas that flicker unpredictably, while others are eerily calm. These differences hint at the complex interplay of rotation, age, and magnetic activity that shapes a star's outer atmosphere. What does this tell us about our place in the cosmos? The sun's corona, for all its mysteries, is just one variation in a vast stellar symphony. Some stars are louder, some quieter, but each one adds its own voice to the chorus. And as we study them, we begin to see our own star not as the center of the universe, but as a single note in an endless song of light and heat. Now, let's bring our journey full circle, back to the sun and the quiet moments when its corona becomes visible to us here on Earth. Now, let's take a moment to step away from the science and simply experience the wonder of the corona. Close your eyes, or keep them open if you prefer, and picture yourself drifting through space, weightless and calm. Ahead of you, the sun stretches vast and golden, its surface rippling with quiet energy, but it's the corona that captures your attention, a shimmering halo of light, delicate as lace yet fierce with heat. You float closer, close enough to feel its gentle pull, like a warm breeze against your skin. The corona's tendrils reach out around you, glowing filaments of plasma dancing in the solar wind. Some twist like ribbons, others stretch into long, graceful arcs, all guided by invisible magnetic currents. The light here isn't harsh, it's soft, almost ethereal, flickering with every shift in the sun's restless energy. Around you, the solar wind hums, a whisper of charged particles streaming past. You might even catch the faint glow of a solar flare in the distance, a sudden burst of brightness against the endless dark. There's no sound, of course, just the quiet majesty of a star's outer breath, wrapping you in its radiant embrace. For a moment, you're not just observing the corona, you're part of it. Connected to something ancient and immense, a force that has shaped our solar system for billions of years. And when you finally drift back, the memory of that light stays with you, a reminder that even in the vastness of space, there's beauty in the details, waiting to be seen. Next, we'll return to solid ground, where the corona's mysteries continue to unfold through the eyes of scientists and eclipse chasers alike. As we bring our journey through the sun's mysterious corona to a close, let's take one last look at the wonders we've explored. This shimmering halo of superheated plasma, visible only during fleeting moments of a total eclipse, holds secrets that continue to puzzle even the brightest minds. From its baffling temperature, so much hotter than the sun's surface, to the way its magnetic fields sculpt fiery loops and streamers, the corona is a masterpiece of cosmic contradictions. Yet beyond the science, it's the sheer beauty of this outer atmosphere that stays with us. Picture those delicate tendrils of light dancing in the solar wind like celestial ribbons, or the way the corona's glow transforms the sky during an eclipse into something almost otherworldly. It's a reminder that the universe is full of marvels waiting to be witnessed, if only we take the time to look up. So the next time you hear about a solar eclipse passing overhead, make a plan to see it for yourself. Stand under that darkened sky, let your eyes adjust, and lose yourself in the corona's ethereal light. And as you drift off to sleep tonight, may your dreams carry you far beyond our world, out where the solar wind whispers through space, and the sun's radiant crown continues its endless, mesmerizing dance. If you've enjoyed this journey through the mysteries of our star, don't forget to subscribe for more cosmic adventures. Hit the bell so you never miss an exploration of the universe's wonders, and let us know in the comments, what's the next celestial mystery you'd love to uncover? Until then, keep looking up and let the stars guide your curiosity. Sweet dreams, space travelers. you.